up against. We're going to do a little bit of vocab here at the top, just so you're used to the words that I choose to use. We're not going to do all the vocab at the top because for our purposes, we don't need all of it. So here's what we're going to do. An absolute value function can be written one of two ways. Okay. And that's absolute value. It's not like 1x1 here. It might be written y equals, or it might be written f of x equals the absolute value of x. They're both the same thing. So don't think it's like a completely different problem or anything like that. So that's one thing to keep track of. When we're doing stuff with a vertex, it works the exact same way that it did when we were doing these before. So, for instance, if I was looking at something, and we'll put an example in here. So let's say, for instance, I've got something like y equals x minus 3 plus 2. Remember, back when we were just doing what we were doing with graphing quadratics, we just stole it from here, basically. Okay? I'm going to do the exact same thing with these.
Hi.
I'm going to steal it just like I did before. I switched the sign, just like before when it was parentheses. Now it's just an absolute value sign. And keep here what's on the outside. Okay? So nothing different than it was before. And it still is going to create my minimum or my maximum, just like it had before with those. So don't let the vertex part throw you off. And then a couple fancy words. A transformation. Ooh. Okay. It changes the size or shape of the graph. In other words, it might make it skinny, it might make it fat, we don't know. But how I find that, and we're not going to get into all the fancy A and X and H and all that other funny stuff, so I'm just going to tell you where to find it. It's a value in front of the absolute value. Okay. So for instance, if I had like 3 times the absolute value of x, that 3 would be the number that would make my graph fatter or skinnier. And I'll explain a bit later how you can tell which thing it's going to do for you. And we can do it all in the calculator. But again, understanding some of the words that are involved really can help out with this. So transformation makes it big, small, fat, skinny, however you want to call it. A translation shifts the graph's direction. Now that direction may be up, it may be down, it may be left, it may be right. And we'll talk about ways you can tell that too. But where do I figure out, what a translation is? Well, those are values inside the absolute value or after the absolute value. And I can even give you a little more information here. When I'm talking about something shifting, okay, if it's a value on the inside, the values on the inside shift it left or right, and if there's a value after it, that shifts it up or down. And I'll even put an example over here to the left, but we're going to practice with these, and we're going to kind of play with it a little bit today. So let's say, for example, I had x minus 4 plus 5. And that's what I was looking to graph. What that would tell me is inside, it's going to be the opposite of what I would think. So if I have a choice between left or right 4, this one would have a translation of right 4, because when I'm looking inside, if it's a minus, it'll be right, and if it's a plus, it'll be to the left. And then the number after, I just go with. So plus 5 seems like it would be up, and it is. So if it's up, it'll be positive. If it's down, it'll be negative. And that's why these note sheets are so important, because there's a lot of stuff to keep track of. And to have it all in one place is always, always a good idea. We aren't going to worry about reflections as much, because that's something that's a little bit further on into this, and I don't want to get too deep into it with only having a few days to work with. So here's how we're going to do this. Okay. There's what's called a parent function, otherwise known as a base graph, which is y equals the absolute value of x, this guy right here. So when I go to graph it, there's a couple of things that I need to know about an absolute value. Number one, it's V-shaped. We're not shaped in a U anymore. It's just straight lines. And we also know, I'll bust out one big word here and that'll be it, is symmetric. In other words, it's reflective. It's like looking in a mirror using the x-axis. So when I go to graph these, and I'm going to show you how to do it manually here in a minute too, because I know you don't always have a graphing calculator available. But we are going to, and I'll show you on the screen here too how this works. If I ever want to graph my parent graph and then start to shift it, here's how it's going to work on the calculator. So I'd go ahead, I'd get it turned on here. I'd hit y equals. Then it gets interesting, because absolute value isn't just a straight button that I have on here. I got to go through a menu. So once I'm at y equals, I'm going to hit math. And once I hit math, that's the button right below alpha here. I want to move over to where it says num. That's kind of my numbers menu. And you'll notice the very first thing there says ABS, which stands for absolute value. So if I move over there and I hit the 1, you're going to see this thing that says abs there. And then we're just going to type in whatever's in the absolute value and close it. So in this case, it's just x. So I'll type in an x, and I'll close it, and that's the calculator's way of saying, I want to graph the absolute value of x. So, just so we can see the picture this time, if I hit graph, okay, there's the V shape, sort of like the one that's on your note sheet. And just like before, if I wanted to look at all the values, I can hit second graph, and my table will be there. And in this case, 0 would be where my vertex is at, because just like before, notice the values on each side of my vertex keep being the same. So there's a lot of things that are similar with this from what we just got done with. So if you struggled with it, it's kind of a second chance to see it and see how it works. And if you're good at it, well, great, because then you've got something easy to work with. So just like before, the highest or lowest point on the graph is called the vertex. And when we're doing the vertex on a parent graph, if it's just the absolute value of x, my vertex is always 0, 0. And that makes sense because my vertex, in this case, is always the lowest or the highest point. In this case, it's the lowest one. But it won't always just be the absolute value of x every time. Sometimes that's going to change a little bit. So we want to play with this a little bit with the calculator, but also how to run into it if we don't have it. So what we're going to do here, where do I want to go? Let's do this first. I'm actually going to skip past that next page and go to where it says example 2. So I guess this is actually the third page here. I want you to see somewhere everything's being done together. And then I basically want to work on some of them with you on the worksheet so you can see how this works. So here's what I'm trying to graph. Now, let's keep this simple. What's my vertex going to be for this particular equation? Remember, I'm stealing it just like I did before from the opposite of what I see in here. So I see plus 2. Yep, so I use negative 2, but I keep the value out here. So it's at negative 2, negative 1. So if I'm going to plot that, I go left 2, down 1, and I'd put a dot in. Now, for my other dots, I have choices. Now, I want to keep this simple. My note sheet here talks about picking a point and finding symmetry. And we don't have to make it this complicated. So here's what we're going to do. And I'm going to show you both ways here. So if I go back to my y equals and I clear it, there's a little more to this one. I'm going to type this whole thing in. So notice the negative 3 at the start here isn't in the absolute value. So I'm going to type the negative 3. But then the absolute value starts. So again, once I get that part, I'm going to hit Math. I'm going to arrow over to the number menu, num, so 1 over to the right. And there's my ABS. I can either hit Enter or I can hit 1, and that'll get me my absolute value. Now this time I have more in here than just x. It's x plus 2. So I type in the x plus 2, and then I close my parentheses, because that's the only part I want in my absolute value, and then I type what's on the end. So what I have here, negative 3 times the absolute value of x plus 2 minus 1 is the same thing. So once I have that, if I want to make this simple, I'm just going to hit second graph. And just like before, if my vertex is in the middle, there's my negative 2, negative 1. Notice, there's the symmetry again. So once I have that, I'm just going to plot the extra points that I have. Now, if I want to draw my chart in, I'm never going to tell you that's a bad idea, especially if you're used to doing it. I'd put my vertex in the middle, and then I'd just start copying the other values that I see. So if my x's go down, I'd have negative 3 and negative 4. If I keep going up 1, and then I just look at the table, and I copy down the values that they give me. And I think I needed to make my graph a little bit bigger, but we'll work around it. So let's see, at negative 1, so left 1, I go down 4, 2, 3, 4. At negative 3, I go down 4. And again, I'm seeing symmetry. Now I know the negative 7s, I'm going to run out of room. 1, 2, 3, 4, 5, 6, 7. We'll wing it a little bit here. And then left 4, down 7. And again, I'm just playing connect the dots to make a nice straight line. So much easier to do than playing around with all this other stuff. You're like, now you'd mentioned, Hardy, you'd mentioned that I can do this without a calculator. And you can, in the exact same way that we did the last ones. So let me show you how that would work. Notice these two values, the y values come out the same. And with these two, the y values come out the same. So here's what I'd do if I didn't have a fancy schmancy calculator to play with. I'd say, okay, I'm going to plug in 0 to this equation. So if I plug in x equals 0, I'd have y equals negative 3, the absolute value of 0 plus 2 minus 1. And I go, okay, well 0 plus 2 is 2. So I have negative 3 times positive 2 minus 1. And that'd come out positive 2, so 2 times negative 3 is negative 6, minus 1 is negative 7. Same answer I got when I did it on the calculator, but I did it manually. But I also know then I'm going to get the same answer for negative 4, so I don't have to do negative 4. And then I do the same thing with these. So let's say I choose to do negative 1. One last time, I only got to do it twice. Negative 1 plus 2 minus 1. I just copied this, but I plugged the x value in. And I said, okay, so negative 1 plus 2 is 1. The absolute value of 1 is still 1. It comes out positive. So negative 3 minus 1 is negative 4, just like when I had it in here. Let's say you're looking at it like, I don't even like playing with this part, Hardy. You know, every calculator scientific that I know of has an absolute value button. So you're like, well, if I have this calculator, why are you showing me? Because on yours, it may be something similar, but you could sit here and say, okay, I'll just do negative 3 absolute value of 0 plus 2 minus 1. Any regular calculator should be able to do that same thing. So whether you're using the graph function, whether you're just typing it in on the calculator and figuring out numbers and plugging them in, they all work the same way. So what I'm going to have you do, I'm actually going to tuck this away. I can't believe I'm going to do this, but we're going to tuck this away. And we're actually going to jump into the actual sheet that we're doing, because I want to show you some strategies that you can use to deal with this. Now I know it says graph each equation and that's all it tells you. I'm going to show you one other little trick that may make this simpler, especially if you don't have a calculator. We're going to do two things on this sheet. We're going to draw the parent graph, y equals the absolute value of x. We're going to name the shifts that we do, and I'll talk about that in just a second. And then we're going to do the shifts. We're going to move them. So here's how this is going to work. On every one of these graphs, and if you don't have a second color to work with, and I mean a pencil and a pen, a pencil and a colored pencil, I don't care. Two different colored pens. I've got colored pencils and I've always got markers in here. And if you need to take one with you, you can. But our first graph on all of these is going to be the same, and I'm always going to do mine in pencil. That parent graph, okay, let me pull this down a little. My parent graph is always going to look like this value-wise. I'm going to start with 0, 0. I'll put a dot. I'm going to have negative 1 and 1 are both going to have a value of 1. And you're like, it's sort of like slope. It is. Okay. And I actually, yeah, I'm going to draw my line through there. Okay. So that would be my parent graph. My y equals the absolute value of x. I've got it. So here's what I want to do. That minus 4 that's outside, what direction of shift is that? Is it left 4, right 4, up 4, down 4? What is it? Let's go back and take a peek here for a minute. Let me pop this. So if I look here, notice on mine, it's outside the absolute value. Okay. So if it's outside or it's after, that's an up or a down shift. And if it's positive, it's up, and if it's negative, it's down. So let's come back. A negative 4 after, which direction are we going? Okay, down 4. You're like, okay, so what was the sense of us just figuring that out? How's that get me the graph? What that means is every point that I've drawn in here so far, if I just go down 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and connect the dots, that's the graph. That's the exact same graph that I would get if I were to go into my calculator, if I have one of the fancy ones available, but you're going to start figuring out my plan is going to go faster than you typing this in. I want the absolute value of x minus 4. And if you look at the picture, it goes below. If you look at the graphs here, 0, 4, negative 4. Well, looky, looky, there's 0, negative 4. 1, negative 3, just like in the chart. 2, negative 2, just like in the chart. So by drawing that parent graph every time, just doing 0 and 1s and 2s and then shifting them, who needs the calculator? Now, well, what happens when a bunch of stuff starts happening? Well, let's see. Let's start with 3, and then we're going to start building into one where a bunch of stuff's going to happen. So I get to 3, and I say, okay, I'm going to draw my parent graph first. So 1, 1, 2, 2. Okay, just draw a light line through there. Okay, so there's my parent graph. This time my number's in the absolute value. Okay. If it's inside, it's left or right. If it's positive, it's left. If it's negative, it's right. So am I going left or right in this case? I'm going left. So it says my shift is left 3. Okay. I take my parent graph, my dots, left 3. Left 3. Left 3. Left 3. And again, I'm not saying you can't use the calculator. What I'm saying is, once you just do the parent graph, you just do a quick shift, it's going to allow you to be empowered. You're not kind of a victim to the machine. Now again, I could do, yeah.
What do I got to do to get that calculator?
I can show you that in just a minute because I got a direct link off my website where you can get this. Yeah, anybody can download this at home and have this available, and you can kind of play with it there too. So let me get done with a couple examples. I'll show you directly right on here. I'll even put it on the video so you can see how that goes. So I get that in, and if I look at it, yeah, it shifted at left 3. Sweet. So don't make life overly complicated. There's ways to make this simple. Let's see. Let's get some multiple stuff going here. Let's flip to the back page. All right, number 9. So on number 9, I'm still going to start with my parent graph. 1, 1s, 2, 2s. If you want to make more, you can. Now this time I got both things to do. What is this plus 2 in my absolute value and the minus 1 outside? Where are my shifts going to be? And it's okay to look at your notes. Where am I going to be going? Okay, left 2, because inside's my left or right. And again, use the note sheet if you need to. And down 1. So how do I do this? Well, again, I start at each point. I go left 2. I probably will do it from this one this time. Left 2 and down 1. 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 But that's what I've got to work myself through on these. And again, you've got to get used to understanding the shifts. Yeah, it's cool that I can put it into the graphing calculator and basically just copy off of there. That's fine. Because even on this one, as long as I understand where the vertex is, -2, -1, I always could get that first point and then go to the calculator. Now that's one thing I hadn't mentioned on the last couple of problems, which I'm going to go back to here for just a second because I want to make sure we get that part. Because some of you might say, well, I'm going to do it on the calculator, but how do you tell where the vertex is if that's not there? And that would be a good question. So here's a way I can rewrite this one. if I don't see a value in there with x, I assume the value that's in there with it would be 0. Because then when I go to find my vertex, it would be at 0, -4. And there it is. So if there's a piece that you don't have, that's a way I could get the vertex, and I still could use the calculator if I'm not sure where that vertex point would be. Similar down in 3. If I rewrote it, it'd be x plus 3, but the 0 would be on the end because I already have the number inside. My vertex is always switch the number in the absolute value, keep the number on the outside. -3, 0 is right here. So I have it. Now if you're like, okay, graphing calculator, cool to have in class. How do I deal with this when I'm not in class? Okay, here's the tutorial on my website. My website, the address does sneak in there at the top, but you can also go to the regular School Center page, click on Mr. Hardy, it'll take you here. But again, it's at huskiesmath.edublogs.org. So if you came here on my very front page, and let me get to my front page here just a moment, because that's in my Algebra 2 file, and you guys don't care about my Algebra 2 file. I was doing a little bit of work earlier. Okay, this will get me to my home page, what you'll see when you first come. Okay, here's my front page. If you go over here to the left where it says Recent Updates, down at the bottom it says Free TI-83 Graphing Calc Online, just like in class. So if you click on that, it'll bring you to another screen where it talks about having this at home. Down on the bottom of that screen, there's a link. If you click on it, it's going to take you to a web page where you can hit this button and you just download the program and you'll have it. Now here's the one thing I'll warn you about with this, because I've had a lot of people download it and they have it and then they're like, well, Mr. Hardy, mine doesn't work. And I'm like, what do you mean? Well, I download it and my click on it and then it disappears. It's not there. So let me show you one other thing so you can understand what's going on and you're like, wait a minute, Hardy, you know, what's going on? When you bring it up on your computer, okay, here's what's going to happen. This screen will come up first, Flash Debugger. You're like, Flash Debugger? And then this comes up. And people are like, see, it didn't give me the calculator. Here's what else you've got to do. Whenever this comes up, you're just going to hit File. You want a new one. And it gives you options on what calculator you want. Well, I like the newest one. I like the Plus Silver. So if I do that and I hit OK, you're like, Hardy, it still doesn't tell me how to get it. Okay? If you hit the play button, miraculously the calculator shows up. And now I can play with it as long as I want to and do whatever and then be done with it. But every time you open it, you have to do that. It won't just pop up ever on its own. So if you kind of have a tutorial now on how to even open it if you want to go that route. But again, it's kind of worth playing around with. It's nice to have a $100 calculator on your computers. You don't have to take it around. You can have it home. So that's kind of our documentary on getting to the virtual TI-83 if you're having issues. And if you get it up there and you're not sure, but again, you'll notice he even has directions on his screen when you pop it up that talks about what I just did. How you've got to double click it to open it, and you've got to go to File and New, and then hit the little play arrow. So there's directions online too if you needed that. But any of those would be excellent ways for you to work on these. And there'll be time in class Monday to work on some too. So that's about